Okay, sir. Thank you. Understood.
Okay.
Sir, I have a small request.
Go ahead.
In case we complete our course before our planned schedule, can we also cover that numerical of engineering knowledge? Just in case if we cover it before our schedule.
बेटा this you will have to ask Captain Sharma. Sharma sir से पूछना पड़ेगा आपको बेटा.
Okay, sir. I'll ask him.
Okay. Yeah, that's right.
Thank you.
Right. Okay. Let me see on the group if anybody is struggling to join. Okay, all of you are familiar with Teams beta? Anybody who is doing it for the first time? I believe most of you are there in the Naval Arc class also. Anybody who is not there in the Naval Arc class?
Yes, sir.
Okay, all right. So beta, you are familiar with Teams, the controls, how it operates. I can see there are 3 people, Ravi, Shiv, and who else? Surya. So familiar with Teams beta?
Yes, sir.
Also Joshua. Okay, all right beta. Good, that's great. My video and sound is coming fine beta. Are you getting it? Any problems anywhere?
All good, sir. Loud and clear.
Okay, great beta. Very good. Okay, all right. Most of the people have joined in. Okay. So few things beta before we start off the topic. Only a couple of candidates are remaining now. Okay, let's start off. So few things before we go into the topic beta. Just to give you a brief intro about how the classes will be running. Before I start beta, have you interacted with me before? Any of you who have attended my classes online or offline, you can raise your hands. Let me have a look. Okay, all right. So 4 candidates. Okay, beta. Great. All right. Okay. So before we start off beta, a few things. Now, when you are joining these Teams meeting, most of you are already familiar with it. But when you join these team meetings, please join with a single device. Connecting with multiple devices may cause some issues. Your connection may get disrupted. So please use a single device. And a few things which you need to be careful, which you need to take care of. Avoid joining on mobile beta. The screen is very small and you will not be able to understand the concept and the working which I'll be showing to you. So avoid small screens like a mobile or any other tab or anything. Try to go on big screen. Okay, use a laptop or a desktop which has a substantial size of the screen so that you are able to easily see the data being shown, and that helps you to understand it well. Now during the class, sometime it may happen that you may face that the video has frozen. Nothing is working. Voice, video, nothing is coming, it has frozen. If you are the only one facing this issue, that means there is a connectivity issue on your side. You can just log out from the meeting and log in again. Once you log out and log in, the freezing will get rectified and you will be able to hear the live running lecture. Now, in case my screen freezes, then all of you are going to have issues and you will come to know when everybody is not able to hear me or see me. In case my video freezes or in case I get disconnected, wait for a couple of minutes in the class. Hopefully, I will be able to join in those couple of minutes. I will be able to rejoin if there is any connectivity issue on the internet broadband on my side. And if there is any issue, I'm not able to rejoin. So then I will certainly drop you a message on the WhatsApp group. So you will come to know that there is some issue and I'll guide you what is to be done further. Another thing which you are already following, keep the videos off. Keeping the videos off gives us better connectivity. The amount of bandwidth which is required reduces and you are able to have a crisp video and audio coming in. So you can keep your videos off and mics, please keep them muted during the presentation. When I'm explaining you something, please keep your mics muted. It prevents any background noise coming from your side and results in a smooth flow of the class. Now, whenever I show you a slide or I cover a particular topic, before moving ahead to the next topic, I am going to give a pause. Whatever doubts which you may have, I will clarify those doubts and then only I will move ahead. So once I complete my explanation and ask you for doubts, you can unmute your mic and you can ask all your doubts. Once the doubts are resolved, only then I'll be proceeding ahead. So we will follow these few rules for the online meeting etiquettes. These are online etiquettes for the smooth flow conduct of the class. Okay, so that was a brief intro. Now, any doubts or any queries which you may have on your side, beta, please go ahead. Okay, that's great. Now you can use the reactions बेटा. अगर आप ऊपर अपने Microsoft Teams के मेनू में देखोगे, there is a react button, and in that react button you have a thumbs up symbol. Okay, you can use those symbols to give me a feedback. Once I ask you, have you understood the topic or not, you can use those react thumbs up symbols. So that gives me an idea that you are connected and whatever I'm trying to explain, that is going well with you. So great, beta, great. That's one thing. And if you have any doubts during my explanation, you can raise your hands also. So that gives me an idea that some doubt is there and I'll be able to take a pause and ask you. Even if you don't raise your hand, after every slide, after every topic, I'm going to give you a pause and ask you for your doubts. Okay, so that was a brief intro before starting. Now today, beta, what I'm going to do is I will first of all show you the examination format. We will have an idea what all topics, what all questions are going to come in our final exam for navigational aids. And I will also explain to you what will be the flow of the class. How are we going to cover the topics? Basically, it is as per the examination sequence only. So that is the first thing which I will show you. And then after that, I will be covering up number one. We will first cover up the basics of radar plotting. That is the first topic which we'll pick up. So that topic will also give you some homework to do from your end. And along with that topic, I will give you an introduction to magnetic compass. So these are the two items which I expect to cover in today's class. Now, before I start moving ahead, I need a little feedback from you that I just want to get an idea about your preparation levels right now, about your familiarity with the subject.
Zero.
Okay. Basically, my idea is कि आपको Nav Aids आपने second mates में भी किया है. You must have done that in phase 2 also. So you have a basic idea and we can directly go into the phase 2 level stuff, or it is totally flat, totally zero, and you want me to start right from bare basics. So that is the idea which I want to get.
Basics, sir, basic.
Sir, basics, sir, basics.
Okay, all right. Okay. So basically you want me to consider that you don't remember, you have forgotten everything and we are starting from ground zero, right? Okay. All right, beta. Great. Great. So let's go, beta. सबसे पहले examination format check करते हैं and let me explain to you what all topics are there. So let's go. Any more doubts in your mind? Anything you want to ask about the class, subject, about me, anything?
Sir, you'll be covering all topics that are related in Nav Aids, correct?
Right, beta. I will be covering up all the topics. Okay.
Okay, sir.
Many a times I feel candidates are clear about the theory-based topic, which are only theory topics. Like I'll give you an example like GPS, Banvas, VDR, topics like that. But still, if you want, I will cover all these topics.
Yes, sir.
The
Just
only
basic explanation or something in these topics as well will be suffice.
I'll do that, beta. I'll do that for all the topics.
Great,
Only
thank you,
thing
sir.
is that I will be giving you the performance standards of the navigational equipment. So that I'll be sending it to you. I'll try to send it today itself. So I would expect that when we cover those topics, or even before that, you go into those performance standards. Now we have a question, a sure short question coming in our exam, which is based on the performance standards. And these performance standards, you need to basically read them and remember them. You have to mug them up. And when the question comes, you have to just write down these performance standards. So I would want you to go through these performance standards at your own pace, at your own time. If any doubts are there, you are most welcome to clarify. But I expect that you go through them and start memorizing them. Okay, there's nothing much to understand in those performance standards. You need to read them and memorize them. So I will send you a file. Keep on going through all those performance standards. If any doubts are there, please come back to me. Go ahead, Ashutosh.
Sir, apart from this, I was asking with regards to phase one, which all topics will be and from when will Marine Gurukul will be starting for phase one?
Okay, beta, for phase one, Marine Gurukul schedule will be released somewhere, I believe, November first week it should be released. And the classes are conducted for 3 subjects. One is navigation, second is naval architecture, and third is for cargo work numerical.
Okay, sir. Thank you.
Okay. Okay. Anybody else having doubts, beta? Okay, great. So let me take you to the examination format now. Give me a minute. I will show you here on the screen. Beta, I hope you can now see the examination format on your screen.
Yes, sir.
Very good, beta. Great. So this is our navigational aids, including compasses topic subject. The final exam is going to be a 3 hours exam, beta. The maximum marks which are allotted are 200 marks and the passing percentage is 50. So you need to get minimum 100 marks for passing. Now in this paper, beta, the first 3 questions are mandatory. Number 1, number 2, and number 3. These are compulsory questions. Number 1 question is on radar plotting. So you get multiple targets, but not more than 3 targets. You need to plot those targets. You need to report them, find out their course, speed, CPA, TCPA, all these things. And you may also be required to take a appropriate action. If there is a close quarter situation, a ROR situation is developing, you will need to take action. So this is question number 1. This is a mandatory question. Then the second mandatory question, number 2, is on gyro compass. This question will involve the theory of the gyro compass as well as numerical based on gyro compass. Most of these numericals are based on gyro errors. There are 2 errors. One is the latitude error, another is the steaming error. So most of these numericals are based on these errors. This is also a mandatory question. And the third mandatory question is on magnetic compass. The magnetic compass, it is mentioned only theory, but you get very light kind of numericals, which do not involve much calculation, but they involve the understanding of the concepts. These 3 questions are mandatory questions. Now, these 3 questions are very, very important questions, beta. Basically, you are passing or failing in the exams. Most of it is decided by the way you answer these 3 questions. If these 3 questions are answered well, then most probably you are through in that exam. And if you make mistakes, there are some fundamental mistakes in these 3 questions, or any one of these is left, then the chances of going through the exam become bleak. So these are very, very important questions. And one of the reasons why candidates sometimes feel it difficult to pass in this exam is that these questions which you get in the exam are not straightforward questions. They are tricky questions. They are not straightforward. Let me give you an example. Now, you can get a question on magnetic compass saying that your ship was at Antofagasta, Chile. And at that time, the cylinder bar, there is a bar which is fitted in front of the compass binnacle. The cylinder bar is removed and taken away from the compass. Now, cylinder bar is one of the characters. And they ask you that there is no change in the heading of the ship, in the magnetic heading of the ship. And then they say later on the ship is taken to some other berth. This cylinder bar is put again, and we observe there is a change in the heading, or the correction is there. So questions like these, which look very surprising at the first instance, these are asked in the exam, and these are not direct straightforward questions. Even if you read the magnetic compass book right from first page to the last page, you will not get these type of questions anywhere. These are basically based on the fundamental understanding of the magnetic compass. So this is what is important in this paper, that you need to understand the fundamentals well and then answer it. As you write your answer, examiner is able to see through very clearly whether there is an understanding of the concepts or not. And if you do not understand the concept, आप इसको answer कर ही नहीं पाओगे. So another question, I'll give you an example. They can give you a question. You see the deviation card on your ship has a easterly bias. Explain. This could be a 25 marks question. Okay. So you need to understand why this easterly bias is there. Easterly bias basically means the entire curve of the deviation card is shifted to the easterly direction. So questions like these are asked, and that is what makes answering the paper tricky, complicated. So the thing is that you need to first understand the fundamentals. Once the fundamentals are clear, you can answer them in your own words. So this is what is important in this paper. And ये जो 3 topic मैंने आपको बताए हैं, radar plotting, then the gyro compass and the magnetic compass. The compasses are going to take most of our time. I would say 1/3 of the navigational aids is magnetic compass, 1/3 is gyro compass, and the remaining 1/3 is all other equipment combined together. So that is basically the importance. And you have to understand especially the compasses very, very well, because if the fundamentals are not clear, the answering of questions becomes very, very tricky and difficult. Okay, so let's go back to the paper. Okay, so these were the three mandatory questions, compulsory questions. Now, other than these three, you have 6 more questions. Now, in these 6 questions, you have a choice of 1 question. You can answer any 5 of these 6. Same thing is mentioned here. Question number 1 to 3 are compulsory. Attempt any 5 questions out of the remaining 6. All questions carry equal marks, 25 marks each. So you see this is a 200 marks paper. 8 questions are to be attempted, 3 mandatory. In other 5 you have 1 question in choice. So 25 8 gives you 200 marks. And whenever you are answering these questions, wherever possible, try to make sketches or diagrams. Making a diagram in a question, it gives you a very good edge. It puts a very good impression on the examiner's mind that the candidate is aware of the fundamentals, the basics, and a well-labeled diagram will fetch you good marks. So try using sketches and diagrams wherever possible in answering these questions. Now, going on to question number 4. This question number 4 is based on autopilot or the course recorder or the rate of turn indicator. Now, on rate of turn indicator, you may get a theory question, simply asking you how will you plan a constant radius turn, or it may be a numerical question. They may give you a practical situation exactly as we face on board. They may tell you there is a lighthouse and you have to plan a turn around that lighthouse, keeping a certain radius. And they may give you, this is the initial course of the ship, this is the final course, this is the speed, this is the radius which you need to maintain, and you have to plan a turn. You have to plot it on your answer sheet or the radar plotting sheet, and you have to explain the procedure. So ROTI may involve a theory question or a numerical question. Then question number 5 is on logs. It could be a Doppler log or a electromagnetic log, or this question may involve a echo sounder. What is the fundamental principle of a Doppler log? What is the fundamental principle of EM log? What is the principle of echo sounder? Or they may ask you about what are the errors which are coming in these equipment, or some specific questions like they may ask you what is ranging and phasing in a echo sounder. They may ask you what is the Janus configuration in a Doppler log. So these type of questions, they come on logs and echo sounder. That's number 5. Then question number 6 is on performance standards of navigational equipment. These are IMO minimum performance standards of the navigational equipment, and these are for GPS, AIS, VDR, simplified VDR, echo sounder, rate of turn indicator, speed and distance indicator, that is the log, STME, speed and distance measuring equipment, that is the log, Doppler log, EM log, and BNVAS, bridge navigational watch alarm system. So you are going to get the performance standards, one of these equipments. So you need to memorize these standards and reproduce them. This is a full 25 marks question. And sometime even in other questions also, you may get a sub part asking you about the performance standards. That may also happen. Then number 7 question is on electronic position fixing system. Mostly this is based on the GPS, global positioning system. You may have a small couple of questions on differential GPS, DGPS, or some other system, a brief question on GLONASS or something like that. So this is the satellite position fixing system. Then question number 8 is on automatic identification system, AIS, or long range identification and tracking, the LRIT equipment. What is the information transmitted in a AIS? What is the information transmitted received by LRIT? Compare the AIS and LRIT equipments with each other. These kind of questions. What are the limitations of AIS? What are the advantages of LRIT? What is the use and utility of the LRIT equipment? Why LRIT is required even though we have a AIS on board? So these kind of questions is what you are going to see in number 8. Number 7 question, which is basically on GPS, may ask you what is the principle of GPS? What are the different errors of GPS? And they may ask you explain the principle of differential GPS or DGPS. Then question number 9 is on VDR, Voyage Data Recorder, and Bridge Navigational Watch Alarm System, one of these two equipment. They can ask you explain the data items which are recorded in a Voyage Data Recorder. They can ask you what is FRM, what are the different parts of FRM. FRM is the final recording medium. What are the different parts in a FRM? Why was Voyage Data Recorder brought into a ship? Or they may ask you explain the need and utility of the Banvas equipment. Why was Banvas equipment required? What is the sequence of alarms and indication in a bridge navigational watch alarm system? So these kind of questions you are going to see on VDR and Banvas. So this is our examination format, beta. Now, any doubts or queries in your mind related to the exam format? Great, beta. Clear.
हम ये कोर्स में सारे कवर करेंगे ना?
Yeah, that's right, beta. I'm going to cover all.
Thank you, sir.
Okay. Even though sometimes candidates get bored when I move on to see the sequence, I will also tell you about the sequence. We are going to follow the same sequence, beta, as we saw in the exam format. I'm going to start off with radar plotting. Then our second major topic is going to be the magnetic compass. Magnetic compass is the biggest topic in Nav Aids. So that is going to be the first topic after radar plotting. Then after magnetic compass, topic number 3 will be gyro compass. So these are two big, huge topics. So इनको पहले cover करेंगे. And then we will move on to the theory-based topics. Autopilot, course recorder, logs, eco sounder, then GPS, AIS, LRIT, VDR, Banvas in that sequence. So sometimes candidates get bored when I go to GPS and AIS, but we will cover all beta. Okay, or as you are comfortable. Okay. So any doubts, queries from your side? Okay, all right. Now tell me, beta, are you able to understand? Is the communication all right? Is my speed too fast, too slow? Any feedback?
नहीं सर, बढ़िया है सर. TCN भी ऐसे ही था, करा दो बस.
Okay, all right, good. Okay, beta, all right. So ready, beta? चलें फिर radar plotting पे? You can give me some thumbs up. Okay, all right. Okay. तो बेटा पहला टॉपिक जो कवर कर रहे हैं that is the topic of radar plotting. And radar plotting में मैं सबसे पहले see I'm considering ground zero now. You have forgotten everything what you have done earlier. You have done radar plotting in ROC, but I'm considering that nothing is remembered. So I'm starting from bare basics. And मैं सबसे पहले आपको एक basic radar plotting concept बताऊंगा. Basically the OAW triangle. How to plot a target and how to report a target, how to get the data of that target. Okay, so ये पहली चीज हम करेंगे. And after that there are some complicated topics in radar plotting. These topics are how to predict a action to take. If you are in a close quarter situation, how to predict what alteration do I need to make to attain a certain CPA. A ship is coming head on collision course and you want to attain a CPA of 1.5 miles. What alteration or what possibility you have, what all options are available to you, reduction in speed, alteration of course, ये second part होगा, which I will not do today. So आज मैं जो basic आपको concept कराऊंगा, after that you have to practice those topics. Practice the basic radar plot before we proceed to the advanced one. So आज basic radar plot pick करेंगे. And after the basic radar plot, if we are left with time, then we will move on to the basics of magnetism. right beta? Okay, all right. Great. So let me put up the PPT for radar plotting basics. Give me a minute, beta. I'll put it up. So beta, are you able to see the opening slide on radar plotting? Yeah, go ahead,
Yes, sir.
Virendra. Okay, all right. Let's move on, beta. In this presentation, we are going to learn radar plotting. So first we go into the basics. Radar plotting is basically the technique of obtaining the navigational data of a target by observing it on the radar screen. It involves the construction of an OAW triangle on the radar plotting sheet. Plotting is generally done using one of the two methods, a relative plot and the true plot. Most of the time, the plotting which is done is the relative plotting or the relative plot. True plot is rarely used in actual practical situations on board. Now for doing the radar plotting, the material which is required is number one, the radar plotting sheet. Then the plotting tools like pencil, eraser, compass, ruler, protractor to draw angles, and a tool to draw parallel lines like a sliding ruler or a set square or a parallel ruler. So beta, any doubts in this? Very good, beta. Moving ahead to the next slide. Let us first go into the references which are used to make the plot. Let us open up a plotting sheet. You can see a plotting sheet on the screen now. Now on this plotting sheet, the letter C, Charlie, is used to denote the center of the sheet. So you can see Charlie point coming up at the center of the radar plotting sheet. The alphabet O, Oscar, is used to denote the relative position of the target at the beginning of the plotting interval. Now, whenever we do radar plotting, we need to have minimum 2 observations of a target. The time interval between the 2 observations of a radar plot is called the plotting interval. Most often, a period of 6 minutes or 12 minutes is used as the plotting interval. Now, Oscar point is used to denote the position of the target at the beginning of the plotting interval. So let us take an example. We have taken an observation, observed a target. We have the range and bearing of the target. These are the two data which is provided to information which is provided by the radar. the range and the bearing of the target. And now we want to plot it on our radar plotting screen. Now for plotting, we need to have a scale. Like you can see, we have mentioned a scale for our particular plot as 1 centimeter equal to 1 nautical mile. So this is the distance scale which we will be using to plot the targets. The bearing can be easily plotted using the graduations on the radar plotting sheet. You can see the graduations. Right at the top you have 0, 0, 0 bearing. Then moving clockwise 0, 1, 0, 0, 2, 0, 0, 3, 0 and so on. So you see these graduations going up to 180 at the bottom, 270 at the left side of the radar plotting sheet, and coming back to 360. So any bearing of the target from 000 to 360 can be easily plotted using these graduations. So let's plot our first observation. Let's assume that the target was here when we started our plotting. So at the beginning of the plotting interval, the target was observed to be here. This was the bearing of the target, that is 020. And let's assume that this observation was taken at 0800. This time is denoted along with the initial position of the target, and it is named as O, Oscar. Charlie to Oscar denotes the range of the target at 0800 observation. This range is measured as per the scale which is chosen, 1 centimeter equal to 1 nautical mile. Now the scale which is used to plot the positions on the plotting sheet should be as large as possible, and this ensures greater accuracy of the plot. Even if a position falls slightly outside the printed circle, it may be used as such as long as it falls on the plotting sheet. Now moving further, alphabet A is used to denote the relative position of the target at the end of the plotting interval. So let's assume that this target was observed to be at this particular position at 0812. So you see we have a 12 minutes plotting interval. The second observation is taken at 0812, and this is denoted by alphabet A, alpha. Now CA, Charlie Alpha distance, represents the range of the target at 0812 hours. And if you extend this CA line to the outer scale, this represents the bearing of the target at 0812. Now if we join Oscar with alpha and extend this line further, this line Oscar alpha represents or denotes the relative movement of the target. And when this line is produced, this is called or known as the relative line of approach. Let us show the line Oscar alpha on our plot. You can see the Oscar alpha line coming up. It is denoted by 2 arrows representing the relative line of approach. Now on this relative line of approach, that is Oscar alpha extended, we can easily find out the closest point of approach with the target. The closest point of approach is also known as CPA. Now to find the CPA, we drop a perpendicular on the relative line of approach, that is Oscar alpha extended, from the center of the plot, that is point C. So from point C, I drop a perpendicular to the relative line of approach, and the point where the perpendicular meets the line of approach is the closest point of approach, the CPA. It is represented by the alphabet N, November. Now, since this is a perpendicular, the angle which is made at November or N is a right angle. Now, if we measure Charlie to November distance, C to N, Charlie to November distance, as per our scale used, this will give us the range of the target at the CPA, at the closest point of approach. So this is the closest that our ship and the target would be at any point of time. So Charlie to November measured as per our scale gives us the nearest approach or the range of the target at CPA. Now moving further, we denote own ship's course and distance in the plot. The own ship course is plotted from point O. We draw our course from point O in the reverse direction. So whatever course our vessel is steering, the own ship is steering, is plotted from point O in the reverse direction. So let me show the own ship course. Starting from point O in the reverse direction, we draw this vector, the green color vector which you see on the screen. And this vector, end of this vector, the free end of this vector is named as W, that is whiskey, and whiskey to Oscar represents the own ship's course and distance in the plotting interval. The plotting interval is for 12 minutes, 0800 to 0812, and vector WO, whiskey Oscar, represents the own ship course and distance covered within this plotting interval. Now, important thing to remember is our course is plotted in the reverse direction from point Oscar. So it is plotted in the reverse direction. The actual course which the ship is steering is whiskey Oscar. Now, once this much of plotting is done, we can now easily obtain the target's course and distance during the plotting interval. How to obtain that? We will join point W with A, whiskey to alpha. Let us join whiskey to alpha line. You can see the maroon color vector coming up on the screen. This maroon color vector, whiskey alpha, represents the target's course and the distance covered by the target during the plotting interval, that is for 12 minutes, 0800 to 0812 hours. Now, whenever we do plotting, we also show the own ship course as an arrow on the circumference of the plotting sheet. You can see in this particular example, own ship is steering a course of 340. So we make a small arrow like the one which you see on the diagram on the plot, representing the course steered by own ship, and along with this course steered arrow, we also show the speed with which our ship is moving. So at present, our ship in this particular example is steering a course of 340 and is moving at a speed of 15 knots. This is also shown in the diagram, and you can see it is matching with whiskey Oscar vector. Whiskey Oscar vector represents the course steered, which is 340, and the distance whiskey to Oscar represents the distance covered by own ship in a period of 12 minutes, which is our plotting interval. Beta, any doubts now up to here?
No, sir.
Very good, beta. Great. Okay, beta, one thing, the IT teams basically tells me that a couple of you have joined with the 2 devices. So please log out from one device, beta, join with single device, right? Okay, all right. So moving ahead now, beta, we have done the basic plot. OAW triangle is made, and we have found out the target course and the distance as well as the speed. Let's go. Now let's move on to our next very important concept of aspect. Aspect is the relative bearing of own shape as viewed from the target. Or it can also be defined in a different way, that is, aspect is the angle between the target's course and the line of sight from the target to own ship. Let us try to understand it from the plot. Let us show the target ship at 0812 hours. On our plot, it will be at location A. We know the course of the target is WA, so target is moving in the direction of vector WA. Let us show the target at 812. You can see the target now on our plot. Let us extend the heading of the target. This blue color line represents the heading of the target vessel. Now let us plot the bearing of own ship from the target. So as viewed from the target, own ship's bearing is what we are going to plot. Own ship in our plotting is at the center of the plot, that is at point C. So from the target, I draw a line passing from point C, and it represents the relative bearing of own ship from the target. Now the angle between these two, that is the target's course and the bearing of own ship from the target, is known as the aspect. Let us show it in the diagram. This red color angle which you see in the diagram is the aspect. Now aspect is expressed in degrees from 0 degrees to 180 degrees, red or green. Red indicates that own ship is on target's port side. The situation which is happening right now in our plot, own ship is on the port side of the target. That's why the aspect is red. Green indicates that own ship is on the target's starboard side. So if own ship was on the target's starboard side, we will denote this aspect as green. Now aspect is a very important data point for collision avoidance because our rules of the road are dependent upon the aspect. Knowledge of the bearing of a target from own ship and knowledge of the aspects gives us an idea of the angle of approach between the two ships. Now this angle of approach is very important from the ROR point of view. Any doubts up to here, beta?
सर जो हमें AC लाइन ड्रॉ करना है सर, वो परपेंडिकुलर होगा या फिर सर कैसे ज्वाइन करेंगे उसको?
बेटा आपको टारगेट शिप को ओन शिप के साथ ज्वाइन कर देना है. दिस इज बेसिकली द लाइन ज्वाइनिंग द टारगेट शिप एट 0812 एंड द सेंटर ऑफ द प्लॉटिंग शीट विच इज एट सी. आपने इन दोनों को ज्वाइन कर देना है और जरूरी नहीं है कि ये आप अपनी प्लॉटिंग शीट पे बनाओ. आप यहाँ पे पैरेलल रूलर या अपने स्केल को रख के इसे डायरेक्टली रीड भी कर सकते हो.
ओके सर, तो एस्पेक्ट हमें जो ऊपर रीड करेंगे हम सर, AC जो ऊपर रीड होगा और ये जो A एक्सटेंड होगा ये रीड करेंगे, फिर सर मतलब माइनस कैसे करेंगे? समझा नहीं मैं सर कि कैलकुलेट कैसे करेंगे वो एंगल.
ओके बेटा, ओके मैं अभी समझाता हूँ. आपने ये अपना स्लाइडिंग रोलर लिया और ये WA की जो डायरेक्शन है ये रीड कर ली. सो यू अलाइन योर पैरेलल रूलर और स्लाइडिंग रोलर विद विस्की अल्फा, bring it to the center of the sheet and you can read कि टारगेट का कोर्स क्या है. Now let us assume in this case the target course comes out to be 280. Okay?
Yes sir, okay.
Okay. Now the second thing what you do is you place your parallel ruler now aligned with alpha to Charlie. आप अल्फा टू चार्ली अपना स्लाइडिंग रोलर रखते हो और आप अल्फा टू चार्ली की डायरेक्शन मेजर कर लेते हो. लेट्स अज्यूम इट कम्स टू 190.
Okay, sir.
Okay. Now the difference between these two, that is direction of whiskey alpha 280, direction of alpha charlie 190. This gives you the aspect. In this case 280 minus 190 will be 90 degrees. So that is how you can get the aspect.
Okay, sir. Understood, sir. And sir, वो रेड एंड ग्रीन का कैसे पता चलेगा सर?
ओके बेटा, अब आप देखो कि जो टारगेट शिप है, आप टारगेट शिप के स्टारबोर्ड में हो या पोर्ट में हो, कहाँ पे हो बेटा अभी? योर शिप इज एट द सेंटर ऑफ द स्क्रीन. वेरी गुड. Whenever you are on port side of the target, the aspect will always be red, and when you are on the starboard side of the target, the aspect will be green.
Okay, sir. Understood. Thank you, sir.
And to put it in very simple words, aspect is basically the relative bearing of own ship from the target.
Okay, sir. From the target.
Okay बेटा, great. चलें आगे.
Yes, sir.
Very good बेटा, let's go.
So can you explain once about this target course? I mean, how to calculate the WLA?
Okay बेटा, you place your sliding roller aligned with vector whiskey alpha. So can you align that whiskey alpha?
Yes.
Once you have aligned it, now you shift your sliding roller, you slide it and come up to Charlie, point Charlie, and you can read off the target course on the graduation at the circumference.
Okay, sir. Thanks.
Okay, great. Very similar to how we read off our course from a compass rose on the chart. So these graduations are basically like a compass rose on the plotting sheet. So you can take your sliding roller to the center of the screen, and wherever it matches with the circumference graduations, that gives you the direction. Okay, beta. Great. Let's move ahead.
Sir, one thing I wanted to ask. So
Bolo beta.
how are we deciding what to subtract from what? If our course is 030 and the bearing is coming at 110, then how are we going to subtract? Like
Okay,
always
beta.
the
Okay.
bigger from the smaller? Or...
Okay. I'll tell you. Beta, you have to first find out what is the target's course. Can you get that from the diagram?
Yes, sir. Understood.
आपको target course मिल गया, so you write it down. Then you have to find out your ship's bearing from the target. From the target, your ship's bearing. That means the direction from alpha to Charlie. वो भी मिल गया बेटा.
Okay.
इन दोनों का जो difference है, difference means bigger minus smaller. जो भी इनका difference आएगा, that difference will be the aspect.
Understood, sir. So always bigger minus smaller, not like from a course to the bearing.
Always bigger minus smaller, beta. Bigger minus smaller will give you the difference, and that will be the aspect.
Okay.
Right?
Understood. Thank you.
Okay, beta. Great. Now, having understood the basics of plotting and also the references which we use in our plot, we are now in a position to work out a practical question. So let us see our first example. You can see the question on the screen. Own ship is steering a course of 340 degrees true at a speed of 15 knots. Observes a target bearing 020 degrees true and at a range of 12 miles at 0800 hours. And the target ship is bearing 017 degrees true at a range of 9 nautical miles at 0812 hours. Find the CPA range, closest point of approach range, and TCPA. TCPA is the time for closest point of approach, course, and speed of the target, and also the aspect of the target at 0812 hours. So we see in the question, two observations have been taken using the radar. First observation has given us the target bearing 020, range 12 miles, taken at 0800 hours. And the second observation taken at 0812 after a duration of 12 minutes. This 12 minutes is our plotting interval. The second bearing is 017 degrees true, and the range of the target at 0812 is 9 miles. So let us now apply our knowledge and plot this target and find out the solution. Let's open up the plotting sheet. You can see the plotting sheet coming up on the screen. Now let's first of all mark the own ship's course and speed on the circumference. Our course is 340 degrees true. So we mark an arrow on the circumference in the direction of 340, and we also mention our speed alongside it, that is 15 knots. Let us now mark the center of the plot, center of the radar plotting sheet as C, Charlie. This is the reference we use for the center. And let us also mention the scale on our plot. The scale which we are going to use for this question is 1 centimeter equal to 1 nautical mile. Let us now plot the first bearing and range. The first bearing is given as 020. So from the center in the direction 020 at a range of 12 miles. 12 miles as per our scale means 12 centimeters. So in a bearing of 020 at a range of 12 miles, we mark our first position. This is the position of the target at 0800 hours, and we know that this position is named as O. Now let's plot the second position of the target. Second observation is bearing 017. So in a direction of bearing 017 at a range of 9 nautical miles. So 9 nautical miles as per our scale is 9 centimeters from point C. We plot the second position of the target. Now this is the position of the target, relative position of the target at 0812 hours, and it is named as A, alpha. So Oscar is our initial observation position. Alpha is our second observation relative position. Now we join O to A and we extend this line further. So joining O with A and extending further, this line gives us the line of approach, LOA. The line of approach is represented by a double arrow. So let us mark a double arrow here. Now from the center of the plot, that is point Charlie, we drop a perpendicular to the line of approach. This perpendicular, the position or the point at which it intersects the line of approach, is named as N, November, and this November represents the CPA of the target, closest point of approach of the target. Now since Charlie November CN is perpendicular to the line of approach, the angle which is made at November will be a right angle. Now if we measure this distance from C to N, Charlie to November, this distance gives us the CPA range. So in this case, we measure this distance Cn and it comes to 1.9 miles. So the CPA range of this target is 1.9 miles. The second thing which you observe is that the target is crossing from the bow of our own ship. Own ship is steering a course of 340, and this relative line of approach passes from the bow side of our ship or from ahead of our ship. Now to obtain the TCPA, we measure the distance from alpha to November, A to N. This distance is measured. Now we are aware that the target has relatively moved from Oscar to alpha in an interval of 12 minutes. So the distance Oscar to Alpha is covered in a interval of 12 minutes. We have also obtained the distance Alpha to November. So interpolating with the approach of the target, we find out how much time it would take for the target to reach at November. So we are aware that the distance OA is relatively covered by the target during the plotting interval of 12 minutes. Hence, we find how long it would take to cover the distance alpha to November by using simple interpolation. So using simple interpolation, alpha November divided by Oscar alpha multiplied by 12. This gives us a duration of 35 minutes. Distance Oscar alpha was covered in 12 minutes. Now from alpha to November, it will be covered in 35 minutes. Now once we have obtained this duration 35 minutes, we can add these 35 minutes to our second observation time, that is 0812 hours. So 0812 plus 35 gives us the time, exact time when the CPA would occur. So that comes out to be 0847 hours for this particular question. Any doubts up to here, beta? Very good, beta. Great. Moving ahead. Let us now find out the course and speed of the target and also the aspect. Now we draw own-ship's course and distance from point O in the reverse direction. So from point O in the reverse direction, we draw our course and the distance covered by own-ship in 12 minutes. So the end of this vector is named as W, whiskey. So you can see the whiskey Oscar vector, the green color vector coming up in our plot. Whiskey to Oscar vector represents own-ship's course and distance in a period of 12 minutes. Now, from point whiskey, we draw a line going up to point alpha. So we join whiskey to alpha. This whiskey to alpha vector represents the target's course and the distance covered by the target in the plotting interval, that is 12 minutes. So you can see the red color vector W to alpha. The direction of the arrow shows the course of the ship. So W to alpha, WA vector represents the target course and the distance covered by the target in the plotting interval, which is 12 minutes. So using our circumference as a compass rose, we now find out the direction of target whiskey alpha, WA, and it comes out to be 273 degrees. So the target's course is 273. We also measure the distance W to A, whiskey to alpha, using our scale, plotting scale, and this distance comes out to be 2.5 nautical miles. So the target has covered 2.5 miles in a interval of 12 minutes. Interpolating this value gives us the speed of the target as 12 knots. So we have obtained the course as well as the speed of the target ship. Now to find out the aspect, we first read off the bearing of our own ship, which is at point Charlie at the center of the plot, from the target ship Alpha. So again, using the plotting sheet, the graduations on the plotting sheet as a compass rose, we find out the direction Alpha to Charlie. bearing of Charlie, that is own ship, from the target, that is alpha, at 0812. And when we read this from the plotting sheet, this bearing comes out to be 197 degrees. We know the course of the target is 273. Let us show the course of the target, extend the course of the target. W2A was the course, this is extended, and the angle between these two lines, the red color angle which you see in the diagram, this is the angle between the target's course and the bearing of own ship from the target, is the aspect, and this aspect in this case is 273, which is the target's course, minus 197, which is the bearing of own ship from the target, and this gives us a value of 76 degrees. And since our ship is on the port side of the target, this is 76 degrees red. So we have obtained the aspect as 76 degrees red. The aspect is also shown in the plot for clarity, but once you have understood the concept, there is no need to show the aspect on the plot. It can be easily calculated in the working alongside the plot. So you can show it in the calculation. 273 minus 197 gives you 76 degrees red as the aspect. Now, one more important thing, we have obtained all the items which were required in this question: the CPA range, the TCPA, the course and speed of the target, and the aspect at 0812. One more thing which can be done from this plot is we can also predict the future positions of the target. We know the OA line extended is the relative line of approach. So if you want to predict the position of a target, the range and bearing of a target at any particular time, it can be done. So let us say if we want to find out the position of the target at 0820, the future position can be predicted. We know the target will be moving on line Oscar Alpha, and we know the rate at which the target is moving. It is covering distance Oscar Alpha in an interval of 12 minutes. So using this rate and this particular line, we can predict any future positions of the target. So that completes our basic plotting question. Two observations given to us: how to find out the CPA, the TCPA, course and speed of the target, and the aspect. Any doubts in this, beta? Clear, beta? चलें आगे?
Yes, sir.
Very good, beta. Great. Let's move ahead. Now moving further, using our knowledge and technique of radar plotting, we can also obtain the set and drift of the current which is affecting our ship in a particular area. In some of the radar plotting questions, this concept may be required. So let us now see how do we use the radar plotting technique to obtain the set and drift of the current. So let's open up our radar plotting sheet. Let's mark the center as C Charlie. Let us show the scale which we are going to use. The scale is 1 centimeter is equal to 1 nautical mile. Let us now show the own ship's course and speed. Our ship is steering the same course 340 with a speed of 15 knots. Now to obtain the set and drift of the current, we need to have a stationary target available to us for observation. The stationary target could be a lighthouse, a buoy, beacon, point of land, anchored ship, anything which is given as stationary in the question. So let's assume that we have a lighthouse inside, and we have observed that lighthouse using our radar, and we have obtained a range and bearing. So let us now plot the range and bearing of that lighthouse on our plot. Let's assume that the lighthouse was observed at this particular bearing and at this particular range. So we have plotted it using the range and bearing on our radar plotting sheet. Let's assume that this observation was taken at 0800 hours. And as per our naming, we name this lighthouse position as O Oscar. Now, after a certain time, after our plotting interval, the lighthouse was again observed, and this time the lighthouse is at this relative position. This is the bearing of the lighthouse, and Charlie to lighthouse represents the range. This observation is taken at 0812 hours, and as per our naming, we name it as A alpha. Now, if we join the line Oscar to alpha and extend it further, this will give us the relative line of approach represented by two arrows. So you can see the relative line of approach. Now, in the next step, we mark our own ship's course and distance. So from point O in the reverse direction, we mark out this vector. You can see the green color vector. The length of this vector is equal to the distance covered by own ship in the plotting interval. The free end is named as W Whiskey, and you can now see Whiskey to Oscar represents the course and distance of the ship within the plotting interval. Now we also join W to A, exactly the same method which we did when we were plotting a target. So we join W to A, Whiskey to alpha. You can see the red color vector joining Whiskey to alpha. Now this red color vector gives us the set and drift of the current. Alpha to W, pay your attention now. Alpha to W gives us the set and the drift of the current during the plotting interval. One very important thing to understand here is when we were plotting a target, the target's course was Whiskey to alpha. But when you are obtaining the set of the current is in the direction alpha to Whiskey, not Whiskey to alpha. It is from alpha to Whiskey. A to W gives us the set of the current. Now, why is that the set of the current is in the opposite direction? It can be easily understood. Let's assume that if there was no current in the area, our ship was proceeding on a course of 340. So the lighthouse would move relatively in exactly opposite direction. So from O, the lighthouse would be moving on this green color track. And after 12 minutes, the lighthouse will be at the location of Whiskey. But instead of falling at Whiskey, the lighthouse has instead gone to the location alpha. Now the lighthouse is stationary, lighthouse does not move. So how has it gone from Whiskey to alpha? Actually, what has happened is the lighthouse has not moved, but there is a current affecting our ship. And our ship has moved in the opposite direction. Our ship was no more at Charlie. Our ship has traveled in this direction because of the current. And relatively, the lighthouse appears to go from point Whiskey to alpha. Therefore, the set of the current is from alpha to Whiskey, shown by the direction of the arrow. And if you measure the distance between alpha to Whiskey, this gives you the drift of the current. This is the drift of the current within the plotting interval. In our example, the plotting interval is 12 minutes. So by interpolating, you can find out the rate of the current also. Rate will be the drift in 1 hour. So this completes the technique of obtaining the set and drift of the current using a stationary object. Beta, any doubts coming up to here?
Sir, can you repeat the how to get the direction of the current, sir? Once again, sir. A to AW.
Okay, beta. Just
Yes.
align your sliding ruler in the direction of AW.
Sir,
First.
not the reading, sir. Like the last sentence you told, sir.
Means your question is how A to W is the set.
Yes, sir. Yes, sir.
How the alpha to alpha to whiskey vector gives us the direction of the current, right? That is the question.
Correct, sir.
Okay, beta. Okay, I will explain to you once again. Now, assume beta there is no current in this area and your ship is moving in a direction of 340. The direction shown by the green color arrow. Your ship is moving in a direction of 340. Now, if there is a stationary target, it will move exactly in the reciprocal direction. Relative motion would be exactly reciprocal. So the lighthouse at Oscar after 12 minutes would fall at point whiskey. Correct, beta?
Correct, sir. Correct, sir.
Okay. Now what we observe is that it is not at whiskey. In fact, it is at alpha. So the lighthouse, how it has gone from whiskey to alpha, the lighthouse cannot move. If the lighthouse has gone from whiskey to alpha, what has actually happened is that our ship has traveled in the direction of alpha to whiskey, this much distance, because of which the lighthouse appears to move in the opposite direction. So our ship has been pushed in the direction of alpha to whiskey by the current, and that is why the lighthouse has gone reciprocally opposite from whiskey to alpha. So this is how alpha to whiskey gives us the set and drift of the current.
Okay, sir. Okay, sir. Thank you, sir.
Clear?
Clear,
Sir,
sir. Clear,
one
sir.
more. Sir,
Go
one
ahead,
more
Beta.
doubt, sir.
Go ahead.
Sir, in the previous example where you told us now WA, we will get the target course and speed also from
Right.
the WA. So, sir, in that case, current won't be applicable, sir. Means how we'll
Okay.
know that that is the true course.
ओके बेटा ओके ना बेटा जो नॉर्मल रडार प्लॉटिंग के क्वेश्चन आपको आएंगे उनमें करंट नहीं होगा. सो आप टारगेट का कोर्स और डिस्टेंस स्पीड जो है वो नॉर्मल मेथड से निकालोगे बाय मेकिंग दिस OAW ट्रायंगल. Now wherever current is required, they will give you a fixed target, either a lighthouse or a buoy, beacon, point of land, or a anchored ship, anything like that. And they will tell you to calculate the direction of the set and drift of the current. So this is how you will calculate. And whatever course and speeds you are getting, you will keep on getting using the same method.
Okay, sir, that is from the examination point of view, but in actual scenario, if you're doing with the radar plotting, so then if there is a current, then we will not get the WA, means that is the true course of the ship, that is, target ship.
No, beta, you will still get it, even if there is a current in the area. Now, let us say there is a current in the area and you are observing a target. Now, when you make this OAW triangle, this triangle will still give you the correct course and speed of the target. The reason for that is that the current will be affecting you as well as the target both. And the current will be taking both of you in the same direction. So irrespective of any current in the area, the target course and speed would still be accurate. So presence of current does not make the target speed inaccurate, beta.
Understood, sir. Understood. Thank you, sir.
Okay, all right.
Sir, मेरे को एक चीज पूछनी थी सर. WO is ship's course ना सर. तो
That's correct.
W पे सर हमने ये assume क्यों करा कि lighthouse was supposed to be at W सर.
बेटा जब हम ट्रेन में चलते हैं तो पेड़ जो है पीछे आते हैं ना. जब ट्रेन आगे जाती है तो पेड़ पीछे आते हैं ना.
Yes sir.
तो अगर हमारा शिप विस्की से ऑस्कर चला गया है तो लाइट हाउस को ऑस्कर से विस्की के आना पड़ेगा.
अच्छा. Yes sir.
अगर कोई करंट ना हो तो वो विस्की पे आना चाहिए 12 मिनट के बाद, पर वो विस्की पे नहीं आया, वो अल्फा पे चला गया. तो हमें पता चला कि अल्फा टू विस्की का करंट है जिसने हमारे शिप को अल्फा टू विस्की पुश कर दिया और रिलेटिवली लाइट हाउस विस्की टू अल्फा चला गया.
Yes sir. Understood.
ओके, और बताओ बेटा, और डाउट्स?
सर ये इसके अंदर ओन शिप की स्पीड नहीं होती तो व्हाट वुड हैव बीन AW?
बेटा इसमें ओनशिप की स्पीड तो देनी पड़ेगी उनको. विदाउट दैट वी विल नॉट बी एबल टू फाइंड आउट व्हाट इज द सेट एंड ड्रिफ्ट ऑफ द करंट.
Okay, sir.
Okay, it is required in all cases. Ownship's course and speed will be present in all the questions.
सर आउट ऑफ द बॉक्स क्वेश्चन सर.
बोलो बेटा.
सर ये रडार प्लॉटिंग शीट A4 शीट में रहता है सर एग्जामिनेशन हॉल में, या नहीं तो बी सम अदर साइज ऑफ द शीट?
नहीं बेटा, दिस इज यूजुअली A3 साइज. इट इज डबल ऑफ A4. ये A3
Okay.
साइज में रहता है.
Sir, can you share? I mean, if anyone is having, can they share so that I can take print out in A3 sheet?
बेटा, anyone has the sheet बेटा in soft copy, you can share it on the group.
I do have it in A4, but I want it in A3, so I want something.
Okay, let me see beta. I have a soft copy. I'll share it with you. Just see if it gets fitted on A4 size.
Okay, sir.
Okay, all right. Or doubts beta? Okay beta, great. So this basically completes a basic radar plot question. We were given the course and speed of our own ship. We were given 2 observations and we wanted to find out the target data. What is the course? What is the speed? What is the CPA? What is the TCPA? So all these items, what is the aspect we have obtained from a basic plot. So I'm going to close the presentation for now, beta. Okay, all right. So beta plotting में हम अभी यहीं पे रुकेंगे. And I will send you a exercise on the basic plot, जिसमें ये जो method हमने किया है, using this method you will be calculating all these items. You will be reporting the target. So ये basic practice आप करोगे. You have a couple of days to practice. हमारी जो next navigation की class है, I think that is on Wednesday, right बेटा? As per schedule.
Right, sir. Other अगली Wednesday.
Right. So you have these 2 days to practice a basic plot. जो एक्सरसाइज मैं आपके साथ शेयर करूंगा, दैट इज बेसिकली द फर्स्ट एक्सरसाइजेज ऑफ शिपबोर्न रडार, कैप्टन सुब्रमण्यम्स रडार बुक. सो ये उसी की फर्स्ट एक्सरसाइज है. इफ यू हैव दैट बुक यू कैन गो अहेड एंड डू द फर्स्ट एक्सरसाइज. मैं भी उसका PDF आपके साथ शेयर कर दूंगा. सो वर्क आउट दिस एक्सरसाइज and once you practice these basic questions, then you will be able to go into more difficult higher level question. How to take action, how to predict what alteration to make or what speed reduction to make. So ये हम next class में करेंगे. That will be on Wednesday. Okay. अब इसके आगे next बेटा जो मैं आपको करवाने वाला हूँ, I am going to take you to the basics of magnetism. Now before that, do you want to take a short break?
हाँ सर, ब्रेक दे दो सर.
Okay, so let's take a quick 5 minutes break. So take a quick break and then be back.
सर ये नाविड्स के लिए टेक्स्ट बुक कौन कौन सी है? एक तो रडार वाली आपने बताई और एक वो इलेक्ट्रॉनिक नेविगेशन इक्विपमेंट, बस ना सर?
बेटा वो इंट्रोडक्शन वाला एक PDF है ग्रुप में, उसमें देखो 4 बुक्स दे रखी हैं.
अच्छा,
One
हाँ
is
हाँ
the
हाँ, मैं देख लेता हूँ सर, देख लेता हूँ.
ओके.
ठीक है सर,
हाँ देख लो
ठीक है,
बेटा.
ठीक. थैंक यू सर.
ओके. Okay, beta, are we back?
Yes, sir.
Okay, all right. Okay, Baiju is there, beta? Baiju?
Yes, sir.
Beta, the IT teams tell me you connected through 2 devices, beta.
Sir, I have some network issues, sir. So initially I logged in my mobile. So later I connected. And for safety standard reason, I'm still my mobile is on. In any case, my laptop is getting off. No network means I can at least can continue with my mobile. That's why.
Okay. All right, beta. All right.
Because I have my Wi-Fi issue in my home. So actually I'm on my second floor. So router on my ground floor. That's why.
Okay, beta, try to get this rectified tomorrow
Yeah,
or in the
sure,
next
sir.
class. Okay.
Yeah, sure. Yeah.
Okay, beta. All right. All right. Great. Good, beta. So, acha, beta, one thing more regarding radar plotting. Now, when you do radar plotting, exactly as we experience in chart work, your answers may not match exactly with the answers given in the book because there are bound to be some plotting errors. Every plotting tool which you are going to use, whether it is the sliding roller, the thickness of your pencil, scale, every instrument is going to have its own error. And when you are reading the directions, the aspect or the target scores, so if the line is very, very small, you see there can be an error in the readings. So a little bit of difference in your answers is perfectly all right. So don't get bothered too much that your answers are not exactly matching. So that much difference is perfectly all right. Main thing is that the fundamental which you have used, the concept which you have used, that should be correct. Right, beta? Okay, all right, beta. Great. So अब मैं बेटा आपको लेके जा रहा हूँ हमारे second topic पे radar plotting. We are giving it a break here. So once you do the basic questions, then we will move on to the higher level problems. अब मैं आपको लेके जा रहा हूँ बेटा magnetism basics. So let's go into it. Let me put up the presentation, beta. Give me a minute. Okay, beta. All right. I hope you can see the magnetism opening slide now. Okay, beta. All right. Let's go ahead. This is our first presentation on magnetic compass. And in this presentation, we are going to learn about the basic properties of magnets and also the Earth's magnetism, the magnetic behavior or the magnetic properties shown by the Earth. Now, our magnetic compass consists of a magnet and it gives us a directional reference basis these two. It follows the magnetic properties shown by the magnets and the directive force is generated or caused because of the Earth's magnetism. So learning about these basic properties and the Earth's magnetism forms the basis of understanding the magnetic compass. We first go into the basic concepts of magnetism. Magnetism is a physical phenomena by which some materials like iron, nickel, and cobalt are attracted towards magnets. Now these kind of materials which are attracted toward magnet are known as ferromagnetic materials. These ferromagnetic materials can also be converted to magnets themselves, and we have two different methods which can be used to convert them into a magnet. These methods are: number one, by use of permanent magnets, and number two, through the presence of a magnetic field. We are going to discuss these methods now one by one. A ferromagnetic material can be converted into a permanent magnet by using two different methods. If a ferromagnetic material like iron is stroked in one particular direction, as we can see in this particular diagram, we see an iron bar which is placed here, and we see a permanent magnet. The iron bar is being stroked by this permanent magnet in one particular way. If this process is repeated at least 40 to 50 times, the iron bar then starts to behave like a permanent magnet itself. The second method in which a ferromagnetic material can be converted into a permanent magnet is if a ferromagnetic material is exposed to a magnetic field and is worked upon. By working upon, we mean that the material is hammered, it is cut into pieces, the material is bent, it is welded, the material is exposed to high temperature, it is exposed to high voltage currents. All these things, if they are done on the material, it gets converted into a permanent magnet. The best example of this method would be when a ship is being built in a yard. The ship is made up of mild steel, which is a ferromagnetic material, and the ship is also exposed to the magnetic field of the earth. At whatever location the ship is, it is being exposed to the magnetic field generated by the earth. And the structures of the ship, which are extensively worked upon, like the hull plate, the keel, the decks, or the bulkheads. These materials, exposed to a magnetic field and extensively worked upon, acquire permanent magnetism and get converted into permanent magnet themselves. Now, using both these methods, if a ferromagnetic material is converted into a magnet, this type of magnetism is permanent magnetism. That means it stays with the material even after the process is completed. The material is permanently converted into a magnet. Clear up to here, beta? Any doubts? Very good, beta. Moving ahead.
Sir, could you hold on? I'm just writing.
Okay. Beta, instead of writing, you can take a screenshot for now. Keep it with you, and then later on you can convert it into notes.
Sure, sir. Thank you.
Okay. Let me know once you are done.
Done, sir. Done. Thank you.
Okay, beta. Great. Now, a ferromagnetic material can also be converted into a temporary magnet, and this is known as induced magnetism. This happens when the ferromagnetic material is in the presence of a magnetic field. To understand this, let us visualize that we have a box full of iron nails and paper clips. We take a strong permanent magnet and we put it in this box. Now, as soon as you take out this permanent magnet, you will see that a lot of nails and a lot of paper clip will be attracted towards that magnet, and they will be hanging on to the magnet, as you can see in this particular image. Now, these paper clips or nails were not showing any magnetic properties till the time they were in the box. But as soon as they come close to a permanent magnet, they start behaving like magnets themselves. So all these iron nails and paper clips have now become magnets, and they have started attracting other paper clips and other nails. The first nail or the first paper clip is attracted towards the permanent magnet, but all subsequent paper clips or all subsequent nails are getting attracted to other nails because all of them have converted into magnets. Now this magnetic behavior is because of the presence of a magnetic field. This permanent magnet which we have here in this diagram shows magnetic field around its location. We have the magnetic field around a permanent magnet, and whatsoever ferromagnetic material is present there, it starts behaving like a magnet. If we remove this permanent magnet from the scene, we take it away from the nails or the paper clips, immediately all the nails are going to lose their magnetic property and they will fall down. Now this kind of magnetism is temporary in nature. This magnetism is going to stay only till the time the magnetic field is present. As soon as the magnetic field is over, they are going to lose their magnetic property. So this is temporary in nature, and this type of magnetism is known as induced magnetism. Go ahead with your doubt, beta.
Yes, sir. For example, when an iron is rubbed by a magnet, there is a chances of that becoming a magnet. Is it right, sir?
Right, beta. That will be a permanent magnet.
My doubt is how is this that magnet is becoming a magnet, the one which we are using it.
Okay. So basically your doubt is that when we stroke a ferromagnetic material with a permanent magnet, how does it get converted to a magnet, right, beta?
No, sir. This is how you are having a permanent magnet, right, sir?
Okay.
How is that created as a permanent magnet? By what means?
Okay, how is that permanent magnet created, right?
Yes, sir.
Okay, beta. Okay. Now see, beta, there are two kinds of magnet. One is known as a natural magnet. Another one is a manufactured magnet, or you can say manufactured in a factory. Okay, the natural magnets are extracted from the earth. You see, we extract this iron ore from the mines. During this extraction, you will find some of the iron ore pieces which we are picking up. They already have some natural magnetism properties. So these are known as natural magnets. They are occurring in nature on their own. And most of the magnets which we use in our day-to-day life, they are used in generators, they are used in magnetic compass. These are manufactured magnet. So they are manufactured using these processes. A permanent magnet is made, and then using that permanent magnet, a artificial magnet is created. So this is one way. Now there is one more way, beta. Okay, let me stop the sharing of the screen. I'll talk to you face to face. So this is one way, beta. Natural magnet हमने हाथ से निकाला, उसको स्ट्रोक किया, तो फेरोमैग्नेटिक मटेरियल जो है वो भी एक परमानेंट मैग्नेट में कन्वर्ट हो गया. Now second method which we have is using electricity. Okay, we can make a electromagnet using a solenoid. Okay, so we use solenoids at many places. हमारे जो ship के walls हैं, most of the walls are based on solenoids. So when you make a ferromagnetic material into a solenoid or an electromagnet, that also can be used to convert a ferromagnetic material into unnatural or artificial magnets. So that is how they are generated. Right, beta?
Thank you, sir. Copy.
Okay, great, beta. Let's go back.
Sir, in that induced magnetism you showed, Nasir, that nails and paper clips. So if they are also like kept for a longer time, they will also get the property of
Okay. If they are kept for a long time under the effect of a magnetic field, just a minute, let me share the slide with you. Give me a minute. Okay. Now, if they are kept under the effect of a magnetic field for a long time, yes, they will also start to get permanent magnetism beta.
Okay, sir, understood. Thank you, sir.
Okay, but for that we need to keep them in presence of a magnetic field for a long period of time.
Understood, sir, understood.
Okay, all right. Let's move ahead.
Sir, cannot hear you, sir.
What about other people, beta? You are not able to hear the slide?
No, sir.
Yes, sir.
Okay, okay,
No,
okay.
sir.
Okay, just give me a minute. When we use the induced magnetism method to make a magnet, the strength of the induced magnet depends upon two factors. The first factor is that stronger the inducing field, stronger will be the induced magnet generated. So how powerful magnet are these nails and paperclip going to become depends upon how powerful this parent bar magnet is. The more powerful this parent bar magnet is, the more powerful these paper clips and nails will be. This is the first factor which decides the strength of a induced magnet. Moving ahead now. The second factor which decides the strength of a induced magnet is the alignment of the ferromagnetic material with the magnetic field lines. If the ferromagnetic material is perfectly aligned with the inducing field, there will be maximum induction generated, resulting in a strong magnet. And if the ferromagnetic material lies perpendicular to the inducing field, there will be negligible induction, resulting in a very weak magnet. You can understand it easily from this diagram. We have a magnetic field in this particular area, and these vertical lines going upwards show the direction of the magnetic field. Now we have some ferromagnetic materials and we place the ferromagnetic materials in this magnetic field. Now this ferromagnetic material, you can follow the laser pointer. This ferromagnetic material is perfectly aligned with the magnetic field lines and it shows maximum magnetic induction, making it a very strong and powerful magnet. Now there is another ferromagnetic material. You can follow the laser pointer. This material is lying at right angles to the magnetic field. Now since it is perpendicular or at right angles to the magnetic field, it shows negligible induction or no induction at all. We have a third ferromagnetic material which is partially aligned with the magnetic field. You can see it is approximately at a 45-degree angle to the magnetic field. Now since it is partially aligned, it is partially induced, and the power of this magnet, induced magnet, will be a partial power. Clear up to here, beta? Any doubts? Very good, beta. Great. Moving ahead. Once a ferromagnetic material is converted into a magnet, a permanent magnet or a induced magnet, in both the cases, it acquires two poles. It acquires a red pole and a blue pole. And it also generates a magnetic field around it. Like you can see in this particular diagram, we have a magnet. It is having two poles, the red pole and the blue pole. And these dotted lines, which are extending outside the physical body of the magnet, they represents the magnetic field exhibited or shown by this particular magnet. Now these lines, dotted lines, which represents the magnetic field of the magnet, are known as magnetic lines of force. These magnetic lines of force, they always come out from the red pole of the magnet and they re-enter into the magnet through its blue pole. As you can see in the diagram, from the red pole side, all these magnetic lines of force, the direction of the arrows show that all these magnetic lines of force are coming out of the magnet. And through the blue end, all these magnetic lines of force are re-entering back into the magnet. In other words, you can also say that these magnetic lines of force, from whichever end they come out, that has the red polarity, and to whichever end of the magnet they are re-entering back into the magnet, that has the blue polarity. Any doubts up to here, beta? Very good, beta. Moving ahead. Let us now see how do these magnets interact when they come close to other magnets. If we bring two magnets close to each other, they can show attraction between them or they can show a repulsion or a repulsive force between them. Whether they will attract or repel each other depends upon the poles which are brought together. When the unlike poles of two magnets are brought together or brought close, they attract each other. Like you can see in the first case, the blue pole of a magnet is being brought close to the red pole of another magnet, and the opposite poles or the unlike poles of the magnet attract each other. So you will see the poles tending to attract. A force appears which makes the poles attract towards each other. And if we bring the like poles or the similar poles of two magnets close to each other, they show a repulsion. They start to repel each other. A repelling force appears. So you can see in the second case, the red and red poles of two different magnets being brought close show a repulsion. Likewise, if we bring a blue pole close to the blue pole of another magnet, again being similar poles, they will repel each other. Moving ahead now, beta. Now we go into one more very important property of a magnet. Now every magnet is going to have a magnetic field around it. In the area surrounding that magnet, there will be a presence of a magnetic field. Now the strength or power of this magnetic field is not uniform at all the locations around the magnet. The strength or power of this magnetic field keeps on changing depending upon the location. Now let us try to understand how this power of the magnetic field or strength of the magnetic field varies. Now we can see a bar magnet here in the diagram. If we draw a line joining both the poles of the magnet and extend that line, this is known as the axis of this bar magnet. and any position in the direction of the axis of the magnet is known as a end-on position. You can see it here also. End-on position means along the axis of the magnet. And if you go perpendicular to the axis of the magnet, we go in a direction perpendicular to the axis of the magnet. This is known as broadside on position, exactly like a ship. If you extend the fore and aft line and if you have any target there in that location, it's called as end on. And if you draw a imaginary line around the beam of the ship in the outward ship direction, that's called a broadside on position. So same way, perpendicular to the axis, any position here is known as a broadside on position. So you can see it here. It is at right angles to the axis of the magnet. Now, how does the strength of the magnetic field vary? The magnetic field strength in the end-on position is twice the field strength in the broadside on position. Just to give you an example, if you go 1 centimeter away from this pole of the magnet and measure the magnetic field strength here, and the same thing is done at broadside on position. You go 1 centimeter away in the broadside on position and measure the magnetic field strength here, you will see that the field strength at end on position is twice as powerful as compared to the field strength at the broadside on position. Clear, beta? Any doubts? Very good.
Sir, I have a doubt, sir.
Go ahead, beta.
Sir, regarding this broadside on position, sir, this can be near to the like blue pole or red pole also, sir?
Okay, now beta, if you are not exactly in the middle,
yes,
then the strength will vary. You
Okay,
see the
okay.
strength is maximum at end on and minimum at broadside, which is midway. Anywhere in between the strength will vary. It will be
Okay.
between minimum and maximum values.
Okay, sir. Thanks.
Okay, beta. Let us now move into the magnetism of the Earth. Now, Earth has magnetism of its own, and the magnetic field of the Earth is identical to the field of a short bar magnet. The magnetic field of the Earth behaves exactly as if God or nature has inserted a powerful short bar magnet inside the Earth. As you can see in this particular diagram, we have the Earth here, and its magnetic behavior is exactly similar to as if there is a short and powerful bar magnet fitted by God or nature inside the Earth in this particular orientation. Now the blue pole of this short bar magnet of the Earth points very close to the geographic North Pole. You can see this green color line going up to this particular point here. This is the geographic North Pole of the Earth. And the red pole of this magnet, short powerful bar magnet, points close to the Earth's south geographic pole. So you can see this green line being extended down below. This green line basically represents the axis around which the Earth rotates. And the points where this axis meets the surface of the Earth are known as the geographic pole. So you can see the geographic North Pole at the top of the diagram where the green color line intersects the surface of the Earth. And you can see the geographic South Pole at the bottom of the diagram where this green color line intersects the surface of the Earth. Now, if we extend the axis of this short bar magnet, you can see there's this yellow color line in the diagram which shows the axis of the short bar magnet of the Earth. Now these axes, they go and cut the surface of Earth at two particular points. The point which is close to the geographic north pole, where the axis of the bar magnet cuts the surface of Earth, is known as the magnetic north pole. And if we extend this magnetic axis, the point where it crosses the surface of Earth close to the geographic south pole, this point is known as the magnetic south pole. Important thing which you can see from this diagram is that the magnetic north and south poles are not at the same location where the geographic north and south poles are. The magnetic north and south poles are slightly away from the location of the geographic north and south poles. Geographic poles are defined by the rotation of the Earth, and the points of the geographic poles on the surface of Earth are fixed. They are permanent poles, they are fixed, stationary and not moving at all. They have been there from thousands of years. On the other hand, the points where the axis of the Earth's bar magnet cut the surface of Earth are known as the magnetic poles. These magnetic poles are not fixed. They are not stationary. They are dynamic in nature, and they keep on changing their location slowly with time. Any doubts, beta? Very good.
Sir, so this is it related to that Earth axis, that 23.4 degree? So that is the geographical North Pole and South Pole?
The 23.5 degree, 26.7 is basically the angle between the ecliptic and the equinoctial. So this has got nothing to do with geographic and magnetic poles. इन दोनों में angle 23 नहीं है बेटा. वो जो angle है, that is between the axis of the Earth and the plane at which it is moving around the sun.
Okay, sir.
Okay, I will show you another diagram regarding the motion of the magnetic poles. Then it will become clear. I'll show you. Let me now show you the motion of the Earth's north magnetic pole over the years. In this diagram, you can see this is a zoomed in diagram of this particular portion of the Earth's surface. The apex of the cone, this particular point, represents the north geographic pole. And as we discussed, the north geographic pole is fixed or stationary point on the surface of Earth, and it has been there from thousands of years and it does not change its position. The magnetic north pole of the Earth, on the other hand, is dynamic and keeps on changing its location slowly. You can see the movement or the motion of the north geographic pole represented by this dotted line in the diagram. This is how the magnetic north pole of the Earth has been changing its location over the years. 1600, 1700, you can follow the laser pointer. Then at 1800, then this was the location of the magnetic pole at 1900, 1948, 1994, 2000, 2007, and still moving further. Moving ahead now, beta.
Sir, what is the reason for this change in magnetic pole?
Okay. Okay. Now, beta, you see, the core of the Earth is basically consisting of molten metals, and that is not stationary, it is moving. So because of that motion, you see the ferromagnetic materials, they are also there in that molten core. Because of that motion, that movement, the magnetic field of the Earth keeps on changing. That's one cause. Second is the human activity. Now we extracted iron ore, let us say from India, and in a ship that goes to Korea, where they use it to build a ship, and that ship keeps on moving. So you see the ferromagnetic material keeps on changing. So human activity is also one of the causes. And the third reason is, beta, basically, you see all the other celestial bodies like Sun, Moon, and the remaining planet, asteroids, they also have a magnetic field. The sun rays which are coming to us, they are also bringing in some electromagnetic radiations. Most of these radiations, we are shielded from those radiations because of the ionosphere, but they affect the magnetic field of the Earth. I don't know if you have heard about solar flares, beta, solar storms. So these solar storms are very powerful electromagnetic radiations which continuously gets bombarded on the Earth. So that also plays a part in changing of the magnetic field.
Okay, sir, understood.
Okay, all right. Let's go back. Now, a few more important points related to the Earth's magnetism. We have seen that the magnetic poles of the Earth are not stationary and they keep on changing their location. The geographic poles are stationary. Now, the difference between the direction of a geographic pole and a magnetic pole at any particular place from the Earth, if you find the angle between the geographic pole and the magnetic pole, that is the variation at that particular place. The geographic poles are the references for giving us true directions, and the magnetic poles are the references for giving us the magnetic directions. A unaffected magnetic compass will point its poles or point its direction towards the magnetic pole, and to get the geographic pole or to get the true directions, we have to apply variation to the magnetic direction. And once we apply the variation to the direction given by the magnetic compass, we obtain the true direction. Now, second important thing to understand is that nature or God has made the Earth such a magnet that its blue pole is close to the geographic North Pole, and the red pole of the Earth's paramagnet is close to the geographic South Pole. Now we are aware that for any magnet, red pole is the one from where the magnetic lines of force come out of the surface of the magnet and they re-enter into the magnet through the blue pole. So you can see it clearly here. From the south magnetic pole of the Earth, which has a red polarity, you will see that all the magnetic lines of force are coming out of the south pole. You can have a look at the arrows representing the direction of the magnetic field lines, and you will see that these magnetic field lines are coming out of the red pole or of the south magnetic pole of the Earth. So anywhere in the southern hemisphere, you will see that these magnetic lines of force are coming out of the surface of Earth. These magnetic lines of force, they go back into the Earth at its blue pole or the north magnetic pole of the Earth, and you can see that anywhere in the northern hemisphere, the magnetic lines of force are going into the surface of the Earth. Clear, beta? Any doubts? Okay, beta. Great. Another important thing to note here is that since the Earth's north magnetic pole has a blue polarity, the Earth's north magnetic pole will be attracting the red pole of any magnet on the surface of Earth. So if we have a freely suspended magnet on the surface of Earth, its red pole will be attracted by the north magnetic pole of the Earth, which has a blue polarity. We are aware that opposite poles of a magnet attract each other. So the blue pole of the Earth attracts the red pole of a freely suspended magnet, and the red pole of that freely suspended magnet gives us the magnetic north direction. We can now see another diagram showing us the magnetic field lines of the Earth. Now, a very important aspect of these magnetic field lines is the angle at which they cut the Earth surface. We are aware that the south magnetic pole of the Earth has a red polarity, and all magnetic field lines, they come out of it. And as you can see here also, in the southern hemisphere, anywhere you see, the magnetic lines of force are coming out of the Earth's surface. We know the north magnetic pole of the Earth has a blue polarity, and all magnetic field lines, they enter into that blue pole. And you can see everywhere in the northern hemisphere, the magnetic field lines are going into the surface of the Earth. A very important property which should be clear in our mind related to these magnetic lines of force is their angle of cut. Now, if you look carefully, these red color arrows represents the magnetic poles of the Earth. Now at the south magnetic pole of the Earth, you see these magnetic lines of force, they are coming vertically out from the Earth's surface. In other words, you can see they are making a right angle to the Earth's surface. They are perpendicular to the Earth's surface, or you can say the magnetic field lines are vertical at the location of the south pole. Now from the south pole, as you go towards the equator, you will see that the angle of these magnetic field lines with the Earth's surface starts to reduce. At the pole, this angle of cut between the magnetic field line and the Earth's surface was 90 degrees. As you move away from the pole towards the equator, the angle starts to reduce, maybe 80 degrees here, 70, 60, 50, 40. And as you go further, and you come close to the equator. Now at the equator, you will see that the magnetic field line's angle of cut becomes 0. The angle of cut was 90 at the pole. Coming close to the equator, the angle starts to reduce, and at the equator, the angle becomes 0. Angle becoming 0 means that these magnetic field lines are parallel to the Earth's surface. Now as you move towards the north magnetic pole, again the angle starts to increase. Now the lines are going into the Earth's surface, but the angle starts to increase, maybe 10 degrees here, 20, 30, 40, 50, 60. And when you reach at the north magnetic pole, the angle of cut between the magnetic field lines and the surface again becomes 90 degrees. You can see at the north magnetic pole, the lines are again perpendicular, making a 90-degree angle to the surface of Earth. Now this angle is known as the magnetic dip or a magnetic dip angle. It is also sometimes called as the magnetic latitude of a particular place. You can see at the magnetic equator, this angle was 0. So the magnetic latitude of that place was 0. As you move towards the pole, the angle is increasing, magnetic latitude is also increasing. And as you reach at the pole, the angle of cut becomes 90 degrees. The magnetic latitude at the pole also becomes 90 degrees. Another important thing which you will see from the diagram is you have the geographic poles also represented by the dotted lines. And we have the magnetic field lines also. We have the geographic equator also. Geographic equator is a great circle exactly midway between the geographic poles. You can follow the laser pointer. It shows the geographic equator now. This geographic equator is a perfect great circle. It follows geometry and it is a perfect great circle. Whereas the magnetic equator is not a perfect great circle. Magnetic equator is represented by this curved line. It is not a perfect great circle. The reason being magnetism is a dynamic property of the Earth. So it is not a perfect great circle, but a curved line. Now using the angle of dip or the angle of cut between magnetic lines and the surface, we can define the magnetic poles as well as the magnetic equator. Let us see what is the definition of magnetic poles. Magnetic poles are defined as those points where the Earth's magnetic field lines are vertical or they are perpendicular to the Earth's surface. As you can see in the diagram, at the location of the poles, the magnetic lines of force represented by red arrows are perpendicular to the Earth's surface. They are making a 90 degrees angle. Go ahead with your doubts, beta.
सर ये 90 डिग्री नहीं समझ आया कि मतलब वो जो डिप है ना मैग्नेटिक लैटिट्यूड वो एट इक्वेटर 0 है 90 डिग्री एट नियर द नॉर्थ पोल है वो थोड़ा समझाओगे?
Okay, beta, okay. Beta, basically this is the angle between the Earth's surface and the magnetic field line. अगर आप मैग्नेटिक इक्वेटर पे देखोगे तो अर्थ सरफेस और मैग्नेटिक फील्ड लाइंस पैरेलल हैं और इन अदर वर्ड्स यू कैन से द एंगल बिटवीन देम इज 0. नाउ एज यू गो टू द पोल, आप पोल्स को देखो, पोल्स आर रिप्रेजेंटेड बाय द रेड कलर एरो. You will see that the magnetic field line and the Earth's surface are perpendicular to each other. The magnetic field lines is up and down vertical. The Earth's surface is horizontal. So that is why this angle magnetic dip is said to be 90 at the magnetic poles.
ठीक है सर फिर ये जो मैग्नेटिक डिप है जस्ट फॉर माय इंफॉर्मेशन इज इट वेरी क्लोज टू द लैटिट्यूड?
It is beta. It is close to the latitude of the place, but not exactly same.
ठीक है सर ओके.
Okay. Great. So this was the magnetic poles. Okay. अब बेटा हमारा टॉपिक अभी आगे कुछ और भी चीज़ें हैं इसमें. So let's stop it here today for the time being and we will continue from here in the next class. हमने अभी मैग्नेटिक फील्ड लाइंस और मैग्नेटिक पोल्स, मैग्नेटिक डिप तक ये कवर किया है. सो इसके बाद का पोर्शन जो है इसे नेक्स्ट क्लास में हम कवर करते हैं. सो आई एम क्लोजिंग डाउन द प्रेजेंटेशन नाउ.
Sir,
Go ahead, beta.
like the magnetic poles, they keep on changing. So this magnetic equator must also be keeping on changing, right?
Yeah, that's correct, beta. That is correct. The magnetic dip of a place keeps on changing very, very slowly. So you have these data also, charts also, which give us the magnetic dip and the change in the magnetic dip every year. That also is available.
Okay, okay, sir.
Okay. Great, beta. Closing down the presentation now.
Thank you, sir.
Okay, beta. All right. So how was our first day, beta? How did it go?
Very good, sir.
Okay,
Excellent,
all right.
Sir,
Okay.
this magnetic compass pretty slow, but actually the concept of magnetic compass is easier, but the questions being asked in the question paper is pretty tricky. So it would be better how to answer, basically how to find which coefficient to answer. That's the difficult part, sir.
Okay, don't worry बेटा, मैं अभी easy से शुरू करके ना आपको easy बनाता चला जाऊंगा आगे तक. That is my aim, that you should be able to answer all the questions. So don't worry.
Okay, sir.
Okay,
सर ये
all right.
मैग्नेटिक के वजह से सर लास्ट 2 बार से फेल कर रहा हूँ सर, पास करवा रहा हूँ सर.
Oh, okay. Don't worry बेटा. We will be spending quite a bit of time on magnetic compass. I know about the issue. Okay, all right. So बेटा आज के लिए हम यहाँ पे सेशन क्लोज आउट करते हैं. सो आई विल बी सेंडिंग यू ए कपल ऑफ थिंग्स. एक मैं आपको रडार प्लॉटिंग की जो बेसिक एक्सरसाइज है वो भेजूंगा. सो यू कैन वर्क ऑन दोज न्यूमेरिकल क्वेश्चंस. एंड सेकेंड थिंग मैं आपको भेजूंगा द IMO परफॉर्मेंस स्टैंडर्ड्स ऑफ ऑल द इक्विपमेंट. सो यू कैन स्टार्ट टू गो थ्रू दोज परफॉर्मेंस स्टैंडर्ड्स. राइट बेटा?
ठीक है सर.
Right, sir, right.
Okay. All right beta. Then we are done for
Thank you,
today.
sir.
And I'll see you in the next class as per schedule. That's on Wednesday. Bye bye till then.
ओके सर, राम राम.
Okay beta. Bye bye.